Thank you, Ruth, for the first session. It was quite insightful. More of a technical session, which for me is always a tough one. But yes, thank you, Ruth. So for the second session, we have Steve from Strangeworks and Srini from TechM. Srini, if you can just turn on your camera and mic. Hi. So now we have two companies that are working in total different areas. Strangeworks is one of our closest partners, or we say closest friends, and TechM, another partner, a very big, as we all know, TechM has a very big brand in India and around the globe. So first, I would like Steve and then Srini to introduce yourself, and then we'll move on to the questions.
Not a problem. Thank you very much for having me. I'm Steve Gibson, Chief Strategy Officer of Strangeworks. I've just listened to the last panel. My background is actually not in physics and science. I started life as an aerospace systems engineer, but I've done various things, and my focus is on the business side. I have some what may be controversial opinions based on some of those questions that we just saw. So I'm sure we'll get into them in a minute. Strangeworks is an organization. We are building a platform to try and make it easier for organizations to use and apply quantum, whether it be in their own environments, using our environments. And so the way we try and approach things is rather than try and bring the customer's knowledge level around what is quantum and how does quantum work and what's a bit and so on and so forth, we try and bring our applications and knowledge up to them so they can understand in their own way of thinking, computational chemists or whatever it is, what is my business problem and how do I apply this new technology? So I'll hand it over from there.
Srini, please go ahead. Srini, you can go ahead with your introduction.
Yeah, good evening, good morning, all. I'm Srinivas, and I'm part of Makers Lab, which is the innovation center of Tech Mahindra. And at Tech Mahindra, I lead innovation management, where I am responsible for ideation, incubation, and commercialization of new ideas. I'm also responsible for outreach. So I'm responsible for creating an ecosystem for all our labs, which includes academic institutions, startups, and hyperscalers. So that's my job at TechBench.
Thank you, Srini. Thank you, Steve, for your brief introduction. So we'll start the session. And the first question can be a very common question for everyone, as we both all have come from the business side. That still, if you see around the globe, around when you go to investors and customers, there is array that what is quantum computing? What are you guys doing? Is it reality or not? So how your organizations are dealing with it from the investor perspective and also from the other end, the customer perspective. Steve?
Yeah, not a problem. I can jump in first if you want. Obviously, we wouldn't all be here if we didn't think that quantum wasn't here and quantum wasn't now. I think from my perspective, the approach I take with whether it be a business or an organization, it's less thinking about quantum as black and white and more shades of gray. So you have classical, you have quantum-inspired algorithms running on classical GPUs. You have quantum-inspired systems that have their own purpose-built hardwares. And then all the way, obviously, up to your IBMs and your Rigettis that have full-blown gate systems. And there's a whole host of different modalities that are around now. And the way we kind of approach these things is any problem that you're looking to tackle and you're looking to get some kind of improvement, rather than saying, what's the best I can do from a classical perspective, it's start thinking about it as a quantum mechanical problem. Start dipping your toe in the water and doing this compare and contrast between the technologies that are around right now. In the last panel, optimization was used as a prime example, and it's probably one of the easiest places for people to get started. It doesn't have to be optimization of particular logistics. It could be optimization of many different things, and just really applying those different way of thinking about these problems. So then sets you up for that future when we get to quantum advantage and bridging that gap from where you are now to the future. Does that answer the question?
Yes, Steve. No, I totally agree. what have been said. And somewhere this needs to be understood more often that the quantum computers are the next gen era that we are in and we to use. So the same question to you, Srini, but the area more touching is on the customer side because TechM being already a part of the system knows how dealing with a lot of customers around the globe. How difficult is it for you guys to make understand even people inside the TechM, the leadership and the customers that quantum computers are here and we will be using them for different purposes?
I think a very important question, Aditya, and I've seen this across discussions on panels. How do you sell quantum computing? How do you sell the
Yeah.
concept of quantum computing? So what has really happened is at our incubation center in Makers Lab, we've been looking at different technologies at different stages. So we started with AI, we started with AR, VR, metaverse, quantum computing. So 2 years back, when we were talking to our management, we said quantum computing for us is a telescopic bet. I'm using a McKinsey word. And now in 2024, we're saying that quantum computing is a microscopic bet, which means I'm going to see some business in the next 24 months. And the reason why we say that, one, technically, you've seen that the number of transistors that you can add, or as they say, the Moore's law is going to die. And there will be a need for us to move from classical to a classical plus quantum, and then eventually to a pure quantum thing. On the other side, if you look at customers, uh, customers also have a technology roadmap. And if you look at tier one customers, they have always been looking at quantum for the last 3, 4 years. Have they got into practice? So, again, using a marketing terminology, in terms of low hanging fruits, we see
Yes.
quantum computing or a mix of quantum and classical used in certain areas like route optimization, fraud optimization, and either simulation in terms of creating molecules or simulating in terms of chemical reactions. So there have been early adopters in terms of customers, and I think that in the next 2 years, we at Tech Mahindra and we in India will see a lot of traction in terms of business related to quantum computing.
Thank you, Srini. And I do agree where the quantum plays will be. On that, on just moving forward with the next question that gives attention to what you said is AI now we have seen that AI coming in more in a more pace, Chat GPT-4 and all these. And where do you see quantum in this place? Because we have seen AI being started, people talking about big data in 2014. People started talking about AI in 2012. Now we are seeing the impact that okay, AI is there, people are talking about it. Do you see quantum is also will be down 5 years the same, or we have reached with quantum at that level now only in 3 4 years only?
So, see, I'll take this question. So, there are two things that we are doing. There are AI has been there for a long time, and then AI has evolved. Today, we are in a stage when we use the word chat GPT, we're talking about generative AI. And
Yes.
generative AI could be in terms of code, in terms of images, in terms of uh, operationalizing the code required, hyper personalization. So AI has actually come of age, and we see a lot of applications happening there. In terms of quantum, uh, what has happened is that quantum has helped us minimize, solve some of the problems which typically takes a lot of time or a lot of bandwidth, a lot of what do you say, compute power. Second is there are some areas where we can use quantum machine learning, which is the next stage of machine learning in AI into quantum machine learning and do it. So I think both of them will supplement each other at some stage, but quantum will have a way forward. They will have their own journey in terms of how they move the industry.
If I can jump in and add to that.
Sure.
So, having previously built a data science consulting firm a number of years ago, organizations wanted to a plug and play solution. How do I use AI? How do I just come and take it? And back then, it was probably 8 years ago at this point. It very much was not a plug and play approach. Everything was particularly custom, and everything that you did You had to really dig into the math and the science and come up with a solution. I think where we're at now with the obviously the GPT chat hype and so on and so forth, we're at the
Yes.
point where you now have an abstraction layer. Those large language models, those implementations, those traditional MLs that you have, they're now just abstraction layers that make it so that the end user can understand it and more easily interact with it. The fundamental science behind what it's doing has not really changed in those 8 years. It's come along, and classical computing and GPU powers and NVIDIA's been doing a great job from that perspective to be able to push the boundaries of what's possible with these and large data and so on and so forth. But at the end of the day, it's an abstraction layer. So now if I look at quantum, where are we at now? I it's here right now, just the same as data science was here 8, 10 years ago, and you could apply it. It will be some time until it's readily available, and I don't think it's ever going to be on your phone and ready to go. But what it will be is there'll be applications that you don't necessarily have to dig into the science of it. You don't have to understand the math of it. One of our partners, actually, Multiverse, do a great example of this on portfolio management application. The end users don't need to understand the math behind it. They just need to know if I give it a list of assets, what's my optimized asset ratios. And so that's where we at StrengthWorks are trying to bring that, I mentioned at the beginning, bring that level up to the end user so that not every organization has to have a physicist on staff that understands the math and the science behind it, but more educate yourself on what the art of the possible is today and what the promise is for the future. And then over time, it will change and come more easily, readily available from a business perspective.
No, I agree. I totally agree. We at also at VQP do the same. When we talk to customers or people, we don't say that you have to learn quantum computing, go out and learn quantum computing. No, we are giving you something new. Go use it. You just see the changes that we are giving you, not what is running behind. You don't need to a quantum expert on your team. You don't need to have a particular physicist, mathematician to understand this thing. So it becomes easier for them also to digest as well. Bring on to that question, Steve. There's so we have been seeing quantum coming out and everybody talking about it. How accessible, and the main question to every customers that I have went to that there was how the infrastructure is, how accessible it is, how easier for us to transform into that infrastructure. How do we get access to quantum computers is a question that we might have always heard. Is it available? We can go and buy it. So how the infrastructure is for quantum computer at this point? If I start from customers down to the academy and down to the students that want to use this infrastructure and know, explore this quantum computers.
Yeah, not a problem. Happy to answer that one. And it's funny. I've seen a lot of these panels, been on a few myself. It's a regular question that comes up, and you normally get someone in the audience that says it's really difficult, it's hard to get access.
Yes.
IBM have been around now for I don't remember when the first system went on, but it's been at least maybe 7, 8 years at this point. There are free systems. It was mentioned in the last panel. Qiskit is always an easy place to get started from a student perspective. The quantum computers are there. They're 4 qubits, 5 qubits. They're not going to solve massive business problems, but it'll get you started in that right direction. Then when you kind of look to now, okay, now I want to increase it from a business perspective. How do I get it? There's a lot of organizations I sell, myself included, and QMware mentioned a minute ago. It's relatively easy. Everything at this point, pretty much everything at this point is on the cloud and cloud accessible. There are a few systems out there that are only kind of either rack mounted or so on and so forth. But at the end of the day, data has to be transmitted from the customer's environment to the end environment. So at some point, it's going to be on the cloud. Even if you bought, and I saw a really interesting panel a while back, one of the big data centers over here bought a D-Wave system and installed it. And they had it there for, I think, 4 or 5 years. It had to constantly be updated because the technology is moving so fast. So I don't think we're in the days of where you buy a large computer, you stick it in a room, and then you don't touch it for years. Everything's evolving so quickly. The processes is changing so quickly. So having that mentality to be open to cloud access and that data transfer, you've got security in there. It was mentioned in the last panel as well. But I think that's from my perspective, it's very easily available right now. I could do it on my own laptop right now. We've actually done it on a plane through plane Wi-Fi before. So it's not like it's difficult. It's just a case of where do you get started?
Yes. So it's more like it's our role to play, bring that awareness among the academy as well as the students that yes, this is available over the crowd, go use it. And Srini, for you on the same terms, how are you exploring and using quantum computers at this point? Because TechM being a very large organization, you have all the partners possible, be it AWS and Microsoft Azure. Then we have new startups coming, right? Like Strangeworks, QMware that are only quantum based. So how at this point TechM is using quantum hardwares?
So I think one very important question, and I think the same question that you asked is how do you access the hardware is a question that was asked to me yesterday when I met the global CEO of an European company.
Okay.
So there was a customer visit, and I was explaining him about quantum computing and how do we see quantum evolving. And he said, like, how do you access? Do you really buy the computers
Right.
and all? I think so. The question that you ask is very valid. Probably there could be some misnomers in terms of when we want to work on quantum computer. Is it like classical where you actually buy the setup, create the setup, and then start working on it? But yeah, like you rightly said, we've all companies and typically Tech Mahindra, since we've been in the quantum for some time, we've been trying to research for some time. We've been having access to all the hyperscalers who are in the quantum space. But the way we are trying to create an ecosystem, I think if you look at is one is the access to quantum computers through all the hyperscalers that you named, uh, and how we build a software or a simulation software around that, and how we test it in the environment. Second is we actually been working with startups. We've explored startups like Kyono Labs and others who have been doing good work in the encryption and the PostScript PQC area in terms of generating random numbers. So, and third is we're also trying to create a set of skilled people who actually can start now working on quantum machine learning, can start actually creating those algorithms and working on it. So in terms of what we're trying to do in Makers Lab, uh, we are trying to build that ecosystem. I think you are one of the partners who's enabling it. So there is an equal role for one us to for the academic institutions where we are trying to get skilled through one of the hyperscalers. Second is with startups where we are trying to create use cases which we can take it to our customers. And third is hyperscalers where we're trying to build our own software layers, take around their hardware or in the environment that they have. So that's those are some of the things that we are trying to do.
No, agree. So whatever in quantum environment, I guess at this point, no company, even the startups don't say that we are competitors. Rather, everyone is coming. What Jalal also said in the last panel, everyone is coming together to give it to the world, to make it more. They have more responsibility now. We have to prove it to the world. No, we are not just talking. We have something. Use it and just see, making it reality. So I guess the important question for the panel and for the year of 2023 is are companies ready to commercialize quantum, and how companies are trying to commercialize quantum? What are the strategies they're adopting to commercialize quantum in era 2020? Or are we in just the phase of research now as well?
So I can start there if you want. We're definitely not just in the phase of research. There's a lot of research that goes on, and I'd like to support it in all the universities and so on and so forth. And they're the ones that are probably more than likely going to come up with the unique algorithm that does something that changes the world at some point. Because they have so many different folks across the entire globe that are focused on algorithm development and pushing the limits. But the question is it here now for from a company perspective? I mean, the answer simply is yes. They're I pretty much guarantee that every single company on the planet at some point has a problem that could be at least started towards that direction of using quantum, whether it be with a quantum inspired implementation or you're looking at QML, maybe it's image classification. The ROI varies. And so the way, from our perspective, the way I took to every organization is you've got your typical triangle of speed versus cost versus performance, right? And you're looking, you pick two, and the other one you don't necessarily get. In quantum, not every problem is necessarily going to give you an improved performance, but there's a chance that you are working on something that's taking a long time. NEC have some really good examples coming out of Japan, where they're doing optimization of scheduling and things like that, um, where you're reducing the man hours down. Now, man hours is money, and to an organization, and if you can put that man to work doing something else, you've now saved it. So I think it's thinking about it from a different perspective. Far too many times do I hear quantum advantage is not here, quantum doesn't beat classical, and so on and so forth. Think about it differently. It's other improvements that can be made on my current processes? And if so, let's now start to think about them from that perspective. There's multiple companies out there giving varying different examples. I have various ones on my own. I'm working with organizations to improve their processes, but it's thinking about it as a whole. So it's one thing to work with an innovation group and do a small POC. You've got to really start at the value point. How am I going to drive value for this organization? Where's the pain point in my current workflows? And how do I integrate this new technology, which is going to be a co-processor? It's not going to replace classical. It's going to be the same as similar type of thing as a GPU is not replaced a CPU. It has its purpose in time, and it has its purpose in that workflow. And so understanding how these workflows come together and starting on that path, I think is what every organization could do right now.
I agree. Srini, you want to jump in?
Yeah, so I think, see, if you look from a pure sales perspective, most of the times the customers gives you a problem statement, and then he says,
Yeah.
"I need this to be solved." It could be route optimization, it could be anything.
Yes.
There are only few situations where a customer comes to you and say, "I need a quantum solution," or "I need an AI solution." They are more bothered about their problem statement getting solved. So we have seen areas where one area was generation of small molecules, where we use both classical and quantum, and we could actually solve that case for them. So primarily, when we're trying to solve problem statements for customers, which technology we use uh, is our prerogative and how it solves best. So I think in terms of solving, we'll definitely see some areas where there could be like Steve said, a quantum inspired solution, uh, where you could see both classical and quantum being used. But again, the positive side to that is we have actually seen some customers, including in India, saying, can we discuss use cases on quantum computing, and can we solve fraud optimization using quantum computing? Uh, so the ray of
Sure.
light is there where customers have quantum computing in their roadmap and they're trying to solve problem statements. Second is where customers have problem statements and we as service providers look at the best options of how to solve them. There we could start from a hybrid approach and then eventually move to quantum computing when we think we are better qualified to solve it and the world is there to accept it. So I think
Yes.
it will be mixed, but FY24 and 25, the Indian FY24-25 will see revenues in quantum computing.
Definitely, I agree.
I
And
do.
the just to add to that, so there's definitely large innovation groups out there that are they're hearing the name just the same as they heard AI 10 years ago. Of it is a buzzword. It's been around for a while, but it's now a mainstream buzzword, not just in the quantum echo chamber. And the interest in how do I apply quantum to it to not just necessarily get a better result. There's a lot of value that can be learned in just the applying the technologies, even if you don't outperform the current implementation. And I completely agree with you on that. I've seen the same on our side as well.
I guess we have been seeing it on the same side. So we have been very clear from the very well. Problems that can be solved by classical, then you don't need quantum computers at this point. You can use quantum computers later, but there are problems that, okay, it becomes a bottleneck for classical computers, or classical computers aren't very good with accuracy precision on that particular computers. Then you bring in quantum computers. At this point of time, ways of using quantum computers are very way. There are many ways to use it, and quantum inspired algorithms that we use currently. And the other thing, I think every quantum company in this phase has their R&D department. It will always be a research side, ever going for next 5-10 years probably. But as truly Steve and Srini said, we'll go into commercialization by this year. Most of the quantum companies will go into commercialization very easily. So before ending the sessions, we have two questions from our audience. One of the questions is more likely for Steve, I guess. What challenges does the data privacy law present?
That is a great question. I mean, data privacy is not new. Okay, so it's been around and should have been around longer. I have interesting takes on people's personal data. Living in America right now, there's no way that my data isn't already out on the internet and readily available. There's been too many hacks of classical systems that are out there. Securing data is important. It was mentioned in the last panel about store now, decrypt later, and there's a lot of work that's being done about post cryptography and a post quantum world. I would say it's early days. I think most of the problems that are being solved and most of the things that are being done, we're not transmitting personal and sensitive data. If you were to get the package of information that's been sent to the quantum computer, you wouldn't know what it was even if you looked at it. So I'm all on board with focusing on quantum and ensuring that future, but also understanding how these systems work. You're not sending people's names and addresses across the internet. You're sending extracted versions of those things. And so it's important to not just think on the dark side, but also think on the positive side. It's a different way of working and a different way of data transmission.
No, great. Because thank you for answering that question. Hope Nitin, your question is answered, because in India, still we don't have a data privacy law at this point. But I guess the government is working to a draft one and get it one, because it's very important at this stage where your data is readily available for everyone. So anything that you see on social media is right in front of your mobile next time. So it is scary. So then another question that we have is from Ruth, that how do you see the field of quantum computing in evolving, and what is the one use case you would like to solve for your personal use case that you would like to see that has been solved on quantum computers? It can be any.
So I'll take that. I think the field of quantum computing is actually evolving. I think if you look globally also, as we rightly said, the ecosystem is getting built. So people understand the demise of transistor. They see how the requirement of compute, the requirement of algorithms to solve uh, difficult problems. And one good thing that's happened is that both in India and outside, there have been good startups that have seen traction. I think including the one like yours, where you have actually started building use cases that will touch the market. So I think
Yes.
uh, quantum computing is evolving. There is a huge market out there. I don't want to give those numbers, saying it's a half a trillion market by 2030 and all. But but more than that, I see that there are use cases. The personal use cases that I'd like to see is that the clinical trials need to come down using quantum computing. Today, it takes about 12 years to get one molecule out. So I think that is one area that I'd like to see happen. But these are all areas like banking, your pharma, and logistics that will definitely see traction. And both in India in terms of globally is in par. So that's what some of my colleagues from Europe were saying, that India quantum ecosystem is as good as any other part of the world. So I think we are evolving in parallel, and it's one ecosystem, and I'm sure there's great future here.
Yes. Thank you, Srini. Steve, your personal use case that you would like to solve on quantum computers?
From my perspective, I think it's and we touched on it a little bit, the intersection of AI and quantum. At some point, the quantum computers get so big that humans aren't going to be the ones programming them. And now AI and quantum being combined to solve problems that we haven't even thought about right now. And that's the stuff
Yeah.
I'm at. It's about, it's not how do I manage a portfolio better or do drug discovery better, but it's how do we find and harness those new things that human society hasn't even thought about yet.
Yes. So sorry, but we have two more questions to take your time. And Jalal, Ruth, and Jitesh, feel free to join in and answer this question. So one of the questions, we are getting a lot of questions now. One of the questions is, what types of problems are best suited for quantum computers? And with the current level of development, which industry can make the most out of it? A very good question, I guess. It's very specific, which industry can make out of it. Anybody can take up. Jite,
Yeah, I
Jalal,
mean,
Steve.
there's a lot of money being poured in on the finance area and the chemistry area. Personally, the reason why these two are important is because the organizations in those two areas are so competitive. That competitive advantage that you have on the portfolios, you make billions of dollars on. Chemistry, first one to market with a new drug, billions of dollars on it. So I think it's those areas that are going to be kind of the leading the charge now and are going to continue to lead the charge for the reason that the ROI is there and they have the budgets to be able to spend on these types of technologies.
Yes. Pharma, I guess pharma and fintech will always be the industries that take up the new technologies, start using it and generate money because they have already a lot of money to invest in new technologies and get things up. Another question that we have from Nirbhay is, as someone who is interested in switching careers to quantum computing, what advice do you have for someone who is looking to enter the field? What are the skills, knowledge, and experience would be beneficial for someone transitioning into a career of quantum computing? So Jitesh, Jalal, if you guys want to answer that, because I guess I have been answering that in a lot of media houses for a long time now, and I have same answer for everyone. Steve, Ruth, you guys can also take up this question.
I'm happy to jump. I can't answer the not being a physicist. I can't answer the technical side. So if you're a data science, well, I have opinions, but I shouldn't be the one to answer them. Is probably the better way to put it. I think Jalal will be a better person from that perspective. But so on the
Jalal,
technical side, transferring over, but I'm not business background. I have a team of people that are not business background, not quantum background, should I say, but they're on the business side. It's very easy to get involved with the industry, and it's not just physicists that is being opened, the doors being opened. There's hundreds and thousands of people at this point around the globe that are in the quantum industry that didn't come from quantum, and so starting the education on what can a quantum computer do, not necessarily from a scientific perspective, but what's the art of the possible from that technology on your business side, and then you pick it up over time. And then there's a transition point at which you're able to speak intelligently about the topic without necessarily understanding all the math and science behind it. So don't be put off if you're not a scientist and you're not a physicist. The business
yeah,
side,
I
a lot of
second you, Steve, on that because I also don't come from a background of very
Absolutely.
physicist. Jalal,
Same here. I'm not a physicist as well. You need to be interested in that area, and you
yes,
need to see the impacts and what it can do like in the field of medicine. I've seen this Austrian scientist. She actually invented um, some algorithms that work together with quantum sensing, because we were talking here only about quantum computing, but we did not even touch the part of quantum sensing. These sensors, they see the world in a completely different manner. They see in a sub atomic particles. So what she did is to invent something. Please, I don't really understand it, but I'll try to explain it the way I understood it. In order to analyze or to when someone has cancer or something, that they go and they get an MRT or they get an X-ray, and then the doctors will take the X-ray and they will say, okay, there's something black, and we have to open up and to take up a tissue to send that to the laboratory and so on. So what she did is she developed some quantum algorithms in order to use these quantum sensors to look into the body of these patients to see in which level the cancer is and what type of cancer it is. So you need to be interested in this field in order to be part of it. This is what I can tell you. I mean, I'm interested as well in it. I'm not a physicist. I'm not a software developer, but I see the potential that is behind it. It's a disruptive technology that will change the planet. It will change the way we think. And as Steve also said before, quantum computers will have a great volume, and we will not be able, like humans, to understand the outcome, the performance that it will generate in the future. Like today, we have 40 entangled qubits within the simulated area. So you have to imagine that it's 2 to the power of 40. It's a number that big. Now imagine what you can do with a quantum processor that has 1 million qubits that are entangled. So 2 to the power of 1 million is crazy. Yeah, you can.
So I
You
totally
don't need
second
any
what
data
Steven
centers anymore.
Shalal are saying, because I also don't come from that background with a very data scientist, analyst, consultant background. I also don't understand what quantum is, but transitioning in a business perspective is very easy. And in the years, I've also learned transitioning from in a technical perspective is also very easy. Only the thing you need to have that, what we say, have that thing to just zeal
Bent of
to,
mind.
and the zeal to understand the new technology. So we have the last questions, and we'll not be taking any more questions, audience. And the last question is focused to Srini. So it's from Supreet Bhaskar. Do major industry players in India seem to lack initiative in the hardware sector? Considering TechM's prominent position in the industry, are there any immediate plans for the company to expand into hardware? Srini, a
I think
very,
very important question. Very
very
important
important
question.
questions
And
for.
so actually, see, I think there is a initiative at the government level to both push creation of hardware in India, and on a different note, creation of silicon for semiconductors in India. But in terms of the services companies, which is IT companies that we all represent, there is no plan to be in hardware. So because our focus has been system integration, software development, product development, uh, business solutions, uh, I think there is no plan to be in hardware. We plan our core competency is building software around the hardware. So we stick to that.
Thank you, Srini, for that answer. I hope the question is answered. So we'll be ending this panel. It was, I think it can be a more long discussion as everybody has to go. And sorry for Steve, it's maybe a very early morning for him to come to the panel.
Not a
Thank,
problem at all. It's
thank
a
you,
pleasure to
guys.
be here.
So thank you everyone for participating and having coming to the panel, agreeing to join this and celebrate Quantum Day with us. This has been a great journey for every one of us from our different organizations when we come, and we hope to achieve something much better in 2023 and organize a in-person meet, a grand in-person meet, somewhere we can all come in and jump for a day and two and celebrate the Quantum Day. Thank you for joining, guys, and even the audience. I hope the session was useful for you. Thank you, Steve.
Thank you.
Thank you,
Thank you.
Srini. Thank you, Jalal.
Thank
Thank you.
you,
Thank you,
thank you,
guys. Thank you for your
thank
time,
you, and
guys.
thank you for organizing it. Bye
Thank you.
bye, ciao, ciao.
Thank you.
Bye. Bye.
Bye.
Thank you. Great questions. Thank you.
Have a happy Quantum Day.